Hello everyone and welcome to No Scanners, a perfect testing ground for malware developers. So in this presentation we're going to introduce ourselves, why we chose this topic, we're going to have an overview of the No Scanners, how they are used by cyber criminals, and we're going to end this presentation by taking a look at an example of an investigation. So my name is Mathieu Gaucheler. I am a subject matter expert at Montego, and I have a background in malware analysis.
Hi, my name is Florian Murschetz. I'm also a subject matter expert at Montego, and I have a background in digital forensics and incident response.
So what are no-distribute scanners? So first of all, NDSs, no-distribute scanner, are also called counter antivirus services by some other organization, like Europol, for example. So they are a scanner, meaning that they will match a file against several antivirus services. But the main difference between this website and, for example, VirusTotal is that VirusTotal will be sharing samples with their partner. This is why it's not very interesting to use VirusTotal for a threat actor, because you do not want your sample to be studied, you do not want your sample to be shared even before you release them in the wild. At the time of writing, there was about 24 NDS that we know of, and 6 of them were active. This concept of no-distribute scanner has been around for a bit more than a decade now, and so far, as we've seen, it has only been marketed to cyber criminals. So we broke down the use of an NDS in 3 different parts: submitting your file, how the NDS is going to analyze it, and then how the NDS is going to report on it. So we're going to break these different steps in the next slides. So the first one is submitting a sample to an NDS. So you can do so by using an API. Like here, we have an example of the Ndse API. It is a script running client side to upload a file to Ndse's backend. And on the left, you have a screenshot of CyberSeal, a cryptor developed by the same threat actor behind Data Protector. A cryptor is a type of software that can encrypt malware to make it harder to detect by security programs. This threat actor decided to create their own NDS and integrate it into CyberSeal, meaning that every time a threat actor was using this cryptor, they would have the result of this encryption checked on the NDS against several antiviruses. So that's how APIs are used in an NDS. But the most common way to submit a file to an NDS is by using their website. Every NDS has a website. They usually contain information about the pricing, what kind of scans are available, and some publicity sometimes. So on the left and on the right, you have 2 screenshots of a submission panel for an NDS, 2 different NDS. The one on the left is very simple. You can upload a file and that's it. Whereas the one on the right is more complex. You have several options to tweak the analysis and have it closer to the condition that your malware would encounter in the real world. You can also choose against which antivirus your malware is going to be matched against to replicate better the condition that your malware is going to encounter. But the main difference between these 2 NDS is not actually the complexity of their submission panel, it is the type of scan they offer. The one on the left is offering static scans, whereas the one on the right is offering dynamic scans. So what is the difference between these 2 types of analysis? Well, static analysis or static scans are basically anything you can do on the file without running it. So this can be, for example, string analysis, like a YARA rule, simply, or checking the export of a portable executable, or checking the entropy of a file to see if it is packed or not. It would be pretty easy to run such an analysis. You just need to have some AV installed, and then you would use the command line to run an analysis on a file. and you pipe the output of this to the NDS website, and that's it. You would have your analysis up and running. That would be also very easy to update your antiviruses. You could all have them on the same machine. Whereas dynamic analysis, you actually need to run the file. And that includes, that gives us a lot of problems if one wants to run a dynamic scanner, because that would entail to have one machine per antiviruses, because if you run the same 30 antiviruses on one machine, they're going to parasite each other and parasite the analysis results, so you don't want that. If you want to run a sample against 30 different AV, you will need 30 different VMs, so it's a lot of processing power. You need a way to revert this analysis, to revert these virtual machines back to the way they were before the analysis, so one analysis does not parasite the next one. And you also need to find a way to update daily these antiviruses. So it's a lot of processing power, it's a lot of logistic. That is a lot of things that you need to do compared to static scanners. And this is why there are fewer websites offering dynamic scans compared to static scans. So we saw how to submit a file to an NDS. We saw how it was going to be analyzed. Let's take a look at the reporting. So on your screen, you have three different kinds of reporting. On the left, you have the simple web page. In the middle, you have an image that you can share, a .png. And on the right, you have several textual representation that you could use to embed these scan results in a web page or in a forum post. It's also possible to use the API to get the analysis results. Let's note that while some NDS offer all these ways of reporting, the main way and the one that is always available on every NDS to report an analysis is the web page. Every time someone uses an NDS, they are going to be given a link to the analysis result that they will be able to share afterwards, and everyone with access to the link can access the analysis results. So what are the business models used by NDSs? Basically, you have three types of plan. So the free scanners that offer static scans only, they seem to make money on ads. Then you have the paper scanners that offer both type of scan, dynamic and static. Although there is a big price difference between static scans and dynamic scans. Static scans are going to be around 10 cents, while dynamic scans are going to be around $3. So this huge price difference is explained by the difficulty to run a dynamic scanner. And then you have a subscription-based one for which you pay for a day or for a month, and you have access to a certain number of scans. So you have a lot of different subscriptions. They range from $15 for a day or $300 for a month. Then to pay for actually these services, to actually use the NDS, you can use different cryptocurrencies, but also some of them actually use some online payment systems like PayPal, BitPay, or WebMoney.
Thanks, Mathieu. And now, as we know how NDSs are working, we talk about their usage. The first is marketing for cybercriminals. Here they make use of NDS reports by showing that their malware is evading antivirus detection. It is most likely used for malware as a service promotion and advertisement, because it is a selling point to convince customers that they don't buy burned malware or fake services. This also generates the trust between the provider of the malware services and the customer. Another common use case we assume is development of malware. With the capabilities of using APIs to test malicious software for detection, it will speed up a successful development process for malware. Another aspect is to use the API capabilities in malware tools, like the CyberSeal crypter, which Mathieu was talking about, which enables user to test their directly generated or packed or crypted malicious code in the same tool. Lastly, others. We assume in this use case group individuals which are testing their software and tools. It could be that red teamers and penetration testers test their tools before an engagement and most likely will burn them after usage. Then we have crackers, which proves that their software is not detected by the antivirus software. On the next slide, we have features that support the previous main use cases. The first one is the AV blocklist checker, which will detect infrastructure exposure and report the bad guys at their domain, which maybe is used for C2 communication, as burned or published. Also, the periodic scans, where bad guys can make use of during campaigns to check if their sample is burned by VirusTotal or different other antivirus software detections. Then now back to Mathieu, and he will tell us something about the user base.
Thank you, Florian. So what we did is that we wanted to explore if these NDSs had a specific community and were used by specific language users. So we took basically a domain of these NDSs, added them in Maltigo, and searched Flashpoint data for posts mentioning them. Then we tied this post to forums, which gave us a breakdown of which forums were used the most to talk about which NDS. So that is the graph on the right, and on the left are isolated part of that graph, the top 3 NDS that are on the top 3 on top right, and the forums that talk about them the most. So this gives us a language breakdown for each NDS by observing the language of the top 3 forums in which these NDS are cited. So for example, for DINCheck, on the top left, the top 3 forums talking about it are Russian-speaking, English-speaking, and Russian-speaking. On top right, Virus Checkmate, you have English-speaking, Russian, and Brazilian Portuguese forums. And on the bottom for noticed.com, you have Arabic, English, and Brazilian Portuguese. So from there, you can see that each NDS is more used by a certain linguistic community.
Thanks, Mathieu. I will dive into a short investigation on the data which we currently have. In this example, on the next slide, we found a post of the tool Xtool 3, version 3, which is a hacking tool, and the features are of it. It's generating usernames out of leaks and also the passwords. It also can scrape proxies from different sources. And it also can try to crack the accounts. So in this case, we found a post on the null.to forum where a stranger posted this tool with also the antiscan.me report to prove that this is not detected by an antivirus software. On the next slide, you can see that we also found this example of Xtool 3 with a different name, with wextract.exe and then a little bit space and then .mue on VirusTotal. The file name itself, it's pointing to the wextract.exe, which is integrated into Microsoft system features for extracting archive files. Also, we found that this tool makes some communication to different domains. Unfortunately, during our investigation, the domains were not available, but we can see in the history that this domain has also served some other malware samples, which are tracked by VirusTotal. On the right side, you can see the cracker alias, which is as a string in the code, and you can see that is the stranger or the alias is Kirmada, and he has distributed this code on cracked.to. We found this example also on the null.to forum, which is referred by the recorded future document on the right. That's it for the first part of our investigations. We're trying to generate more data and working on this currently. And if you have any questions, give us a shout and just send us a message on Twitter or directly on LinkedIn or now.